expressions where you might have an exponent. So the first little tiny group at the top all have either a 1 or a 0 involved in all the questions. So just see what you remember from Algebra 1. Okay, if I just said, let's do 5 to the first power, anything to the first power is going to be kind of a similar answer. So if I have 5 to the first power, does anybody know what that would be? Just 5. Okay, anything to the first power is just that thing. So like if I had 10 to the first power, that'd be 10. 11 to the first power, that'd be 11. Okay, now, my second question, I have 1 to the 5th power. Yes, 1 to any power. 1 to any power is just equal to 1, because you're just multiplying like 1 times 1 times 1, 5 times for that example. Okay, now this one, I don't know if you guys will remember. So I have 5 to the 0 power, and I'm actually going to explain where this comes from kind of underneath here in a second. But does anybody know what 5 to the 0 power? Yes. Anything to the 0 power is 1. I'm actually going to use that space underneath to kind of explain to you where that comes from. And then the last question I have 0 to the 5th power. What do we think? Zeros. 0 to any, it's like 1 to any power is 1, 0 to any power is 0, because you're just multiplying 0 by itself that many times. Okay, now, if you've ever wondered why everything to the 0 power is 1, I'm going to kind of try and explain that to you with this little example underneath here. Okay, now I know this is not super normal, but I'm going to start all the way over here to the far right. So 4 to the 3rd power just means 4 times 4 times 4. So you're multiplying 4 by itself 3 times. This is 64. 4 squared, 4 times 4, multiplied by itself, which is 16. And anything to the first power is that thing. So 4 to the first power is 4. Okay, now I just want to show you guys this really quick. If you're basically adding a power of 4 each time you multiply across there. So if I were to actually go backwards here and remove a power of 4, it would be like dividing by 4. And this is true. Like if I take 64, divide by 4, that's 16. If you take 16, divide that by 4, that's 4. 16 divided by 4 is 1. So if I continue with that pattern, then the next step should be 4 divided by 4, which is why anything to the 0 power is 1. Because the step before it, it would just be that number divided by itself, whatever base you were working with, but that's why that is always 1. Now, you can actually continue this pattern. So it should just be the previous step divided by the base of my exponent. So for this one, it should just be 1 over 4. So 1 divided by 4, we would write that as 1/4. Now, the next two I'm going to jot down here for you. If you were to divide that by 4, that fraction, 1/4 divided by 4, if you did like a keep, change, flip, it's really going to sneak that 4 into the denominator and they get multiplied together. So the denominator and the number there, the 4 would get multiplied. This is 1 over 16. And then if you do it one more time, we could keep this going forward or back on this line. I'm just giving you guys a couple examples. But if I would divide by 4 again, this is 1 over 64. And that's going to lead us into our little bit of our next property here. But I just want to show you guys this. So like 4 squared is 16. 4 to the negative 2 power is 1 over 16. And like I have 4 to the negative 3 and 4 to the third. 4 to the third is 64. 4 to the negative third is 1 over 64. So that's going to go with our negative exponent rule, which I'm going to write underneath here. Okay, negative exponent rule. I'm going to use a variable to write this out. But if you have x to the negative n power, you can rewrite that as 1 over x to the positive n power. And x could represent a variable, it could represent a number, but if you have a negative exponent, it's not considered a simplified expression. So if you don't have a fraction, I just turn it into a fraction, and then I tell people to move it and lose it. So you move it to the opposite part of the fraction. Okay, now just a little tiny piggyback on this. If you have, let's say I had 1 over x to the negative n, and the negative exponent was in the denominator of a fraction. If that's the case, this actually moves up to the top, and it's still move it and lose the negative, move it and lose it. So that would become x to the positive n power. So we're just going to practice this in this first little example. If you have a negative exponent, numbers or variables, either one, if you have a negative exponent and you don't have a fraction, we're just going to make a fraction real quick. So I'm just going to write that over 1. Now, to get rid of the negative exponent, you're just going to move it to the opposite part of the fraction, and you just lose the negative exponent. So that 7 to the negative 2 would come down. This would be the same as 1 over 7 squared. And then notice that negative exponent, it's not a negative answer, it's actually just going to make a fraction. So we're not dealing with any negative numbers here. We could simplify that a little bit. That'd be 1 over 49. All right, the example I've got next to this, I've got negative exponent in the top of the fraction and the bottom of the fraction both. So if it's negative in the top, you just move it to the bottom and lose it. This negative in the bottom, we're going to move it to the top and lose it. So this would be 2 to the positive third power over 6 squared. And then if you can, go ahead and simplify these. So 2 to the third power is 8, 6 squared is 36. Let's see, both of those guys are divisible by 4, so I can reduce that a little bit. That'll be 2/9 as my answer. So you can use your calculator to do any of these questions that have numbers if you want to. If you got a variable, again, if you have a negative exponent, if you don't have a fraction, just turn it into a fraction real quick. So I have a to the negative 5th. So I'm just going to move this and lose it. So it'd be 1 over a to the positive 5th power. And then for the last one here, just move it and lose it. I've already got a fraction, but if it's negative in the bottom, you're just going to move it to the top. And so this guy, the fraction would actually cancel out for that last example. That would just be a to the positive 8. Does anybody have a question? All right. See if you guys remember any of these rules. So I've got like a rule, and then I've got a couple examples to practice. All right, so product rule. If I have x to the n, so x to a power, times x to a different power. I'm just going to use n and m for my exponents. Do you guys know what you do with the exponents if you're multiplying like bases? You add them. Okay, so this would be the x to the n plus m power. That would be your rule. All right, now I'm going to write this out just for the first one, just so you can see it. You don't have to do this on any questions. You should just add those exponents, but x to the third means I would be multiplying x by itself 3 times, and x to the 5th, you'd have 1, 2, 3, 4, 5, and instead of writing all of that out, it's so much easier to just say, okay, I have 3 here, 5 here, so if we multiplied them together, we would have 8 total. So you don't have to write them out, but that's where that comes from. All right, what if I have 2 to the 8th times 2 to the 6th? How could I simplify that? Both of the bases are 2. What would your answer, and you don't have to, we'll just leave it in exponential form. You don't have to actually multiply it out. Dakota, what do you think? Okay, plus. All right, now, I don't know why, but sometimes if it's a number, people would write like 4 to the 14th. Don't do that. You keep the base exactly the same. So you're doing 2, it would be 2 written out 8 times, 2 written out 6 times, so the total would be 2 written out 14 times. So don't change the base. I think that throws some people off sometimes if it's got a number instead of a variable as the base of the exponent. Okay, now my last one is like super mean. I have 5x to the negative 4th times 7x to the 10th. Okay, what do I do with the 5 and the 7 in that problem? Do you guys know? Yes? You just multiply them. Okay, I about had a heart attack. Okay, so just multiply the numbers. So literally just like 5 times 7 is 35. Okay, now, if I was doing this problem, I would just go ahead and add the exponents. If you end up with a negative, then take care of it after that. But sometimes you will and sometimes you won't. So if I do x to the negative 4th, this would just be like negative 4 plus 10 just adding those exponents, so that would be x to the 6th. If I ended up with a negative exponent, then we could make a little fraction, but I don't there, so I don't have to worry about it. So if you multiply like bases, the bases there being the x's, you just add the exponents, and that works also if it's a negative exponent. So negative 4 plus 10 would give me the 6. All right, is anybody having a question? Okay, I'm going to write down the quotient rule, but I don't actually use this very often. Okay, so let's say we had like bases, and I have x to the n over, same base, but x to a different power. Do you guys know what that rule is for what to do with the exponents there? Like, what do I do with the n and the m? Yes, you subtract. Okay, so this is x to the n minus m. Now that does matter if you want to use this rule. Whatever the exponent is in the top of the fraction, you have to subtract the exponent in the bottom, because when you do subtraction, the order does matter. When you do addition, it doesn't, but when you do subtraction, whatever's in the numerator, that has to subtract the exponent in the denominator. Okay, now, you feel free to use that method. Here is how I do these problems. All right, so I have a little example here, right? I have x to the 5th over x to the 3rd. What I would do for this problem is I would ask you, where do I have more x's, the top or the bottom? The top. How many more? Okay, so it's x squared. That's how I do it. There's more in the top, so the fraction's actually going to get canceled out. If you guys wanted to look at it, and again, you don't have to write this out, but I would have x multiplied by itself 5 times on the top, 3 times on the bottom. 3 in the bottom cancel 3 in the top, and so I'm left with 2 in the top, but it might just be a little bit easier. Ask yourself, where do you have more? Okay, so if I look at x to the 4th over x to the 7th, where do I have more x's, the top or the bottom? How many more? 3 more. Okay, so you can't leave nothing in the top. So what should I leave in the top of the fraction? 1, right? So if you have a fraction, it exists, so you can't leave a 0 up there, but I got 3 more x's in the bottom, so just be 1 over x to the 3rd. That might be a little bit faster. If you want to actually do the subtraction, you would have x to the 4 minus 7, which would be x to the negative 3, and then you'd have to get rid of that negative exponent. I usually just ask myself, okay, where do I have more? And then if you can answer that question and how many more, just put it in that part of the fraction. Okay, now last one. I'm going to grab my calculator because I'm being a little bit lazy. If you have just numbers in the problem, like I have 18 and 24, this is a fraction. So we're doing division here. So I'm not going to use exponent properties with those. And I'm going to show you my favorite keys on the graphing calculator if you don't already know this. Okay, so I am going to literally type it, and I know you could reduce this by hand, but I'm just going to show you. Okay, so I'm going to do 18 divided by 24. That's the fraction I have there. Hit enter. And I know you could do this by hand, but just in case. After you have that decimal on the screen, because sometimes they're not always nice, if you come down that 4th button on the left side, math, that brings up this big menu here, and the very first thing will convert that to a fraction. So just math, enter, enter, and it will take that fraction and convert it into lowest terms. So if you want to do it by hand, please feel free. But if you want to use your calculator to kind of save some time, you can do that too. So that fraction, just like you would normally reduce a fraction or use your calculator to help you, would be 3/4. And then I would say to you, okay, where do we have more a's, the top or the bottom? How many more? Okay, so then for the exponent properties, that's how we would simplify the exponents. And I'm not trying to confuse you, but if you're multiplying, like we were doing the question up here right above this, like you just multiply the numbers like you would normally multiply the numbers, add the exponents if you have exponential part of your question. Here, if you're working with division, actually divide the numbers or reduce the fraction, and then work with the exponent properties, just where do you have more, the top or the bottom. All right, and I got one more property on this side. This is really quick. So the power rule, let's say I had my base of x to a power, and then I had a power on the outside of that. So I'm going to say x to the n and then to the m power. Do you guys know what to do with the exponents in that scenario? You multiply them. Okay, so this is n times m power. All right, now, just really quickly, like, so I have n squared to the 4th. This should just be n to the 8th. Absolutely don't have to write this down. I'm just going to show you real quick. N squared to the 4th would mean I had n squared 4 times. N squared is n times n. And instead of like writing all that garbage out, isn't it way quicker to just do 2 times 4? But that's where that comes from. So n squared to the 4th would be n squared 4 times, which would give you 8 n's. Now, if you got a negative, works the same way. 5 times negative 2, this would be n to the negative 10th. The only thing we'd have to do just real quick, they're not considered simplified if you got that negative exponent. So I'm just going to create a fraction if I don't already have one, and then I can move it and lose it. So this would be 1 over n to the positive 10th power. Is anybody having a question? Now, these two are really similar, so I'm going to just show them to you at the same time. I have the product rule and the quotient rule. All right, so in parentheses, let's say I have a product. That means I'm multiplying a couple things together, maybe 3 things. I'm just going to do 2. Let's say we have a times b, and then we have an exponent on the outside. Now, what goes on there if you have a product, so I don't have adding or subtracting, I'm just multiplying inside those parentheses, then it works like a distributive property where everything inside those parentheses would get that exponent. That is not true if you have adding or subtracting, but I don't have adding or subtract. I just have a product here. So this would be the same as a to the n power times b to the n power. And some of these can kind of combine sometimes with some of the other properties we talked about on the front, because maybe your product already would have an exponent on one of those things. So we're going to practice that in the examples underneath here. And then quotient to a power, very similar. Quotient just means I'm dividing. So let's say we had a over b. No adding or subtracting, right? Just something over something else. And we have that to the n power. Same thing. It's like a distributive property to anything inside the fraction here. So this would be a to the n over b to the n to simplify that. So we're going to I've kind of got a combination of these two properties in the example underneath here. So if I have 2a to the 7th, and that's to the 5th, this is especially tricky for people if we have numbers. We have to do 2 to the power, and then the other part of this is actually one of the properties we just talked about on the back, power to a power. So this would be 2 to the 5th, a to the 7th to the 5th. If I have power to a power, I'm going to multiply those exponents. So that would be a to the 35th. And then do you guys know how to do, I know you know how to square stuff. Would you know how to do like 2 to the 5th power on your calculator? You know, the little caret button. I'll just show you if you haven't seen it before. So like if I do 2 and then move this up so you guys can see it. The little button right above the division key, it looks like a triangle with no base. It's called a caret. If you have an 83, it will actually type that symbol on the line. If you have an 84, it will give you an exponent. But you could do like 2 to any power you want, but 2 to the 5th power, there's going to be 32. And then a to the 35th there. And then that's all you have to do. And some of these you might just know off the top of your head. So if this one is a quotient to a power, because I'm dividing a couple things, so this would be 10 to the 3rd, and then I have this power to a power we talked about on the back, x to the 9th to the 3rd. We're going to multiply those exponents. So 9 times 3 is 27. Only other thing I could do there maybe real quick would be 10 to the 3rd is actually equal to 1,000. Maybe simplify that a little bit. Is anybody having a question? Okay, now this guy has negative exponents, and it's totally up to you. You can deal with the negative exponents first, or you can put, go ahead and distribute the 3rd power. It's completely up to you. I'm just going to go ahead and give everybody a 3rd power, and then I'll deal with the negative exponent when I'm done. All right, so this would be 6 to the 3rd. All right, negative 5. So power to a power, negative 5 to the 3rd, we would do negative 5 times 3. So that's going to be negative 15. So this won't be quite simplified because I'm going to have to get rid of that negative exponent. And then 4 times 3 is 12. Okay. Now, I'm going to make a fraction because I don't want to have that negative exponent. You're only going to move what has the negative exponent. So don't move anything else. This is going to come down to the bottom of the fraction. We move it, we're going to lose the negative exponent. Now, I'm just going to simplify this. I don't have a ton of space. 6 to the third power is 216. And y to the 12th, we'll just leave that where it's at. X to the then positive 15 comes to the bottom of the fraction. And then that's all simplified. Does anybody have a question? Okay, now, anytime you're working with a fraction, which I know we just did on B, but there's nothing I could have simplified there. If you're working with a fraction, I would always tell you to maybe try to simplify whatever is going on in that fraction before you apply any exponent outside here. So for example, on this one, can I divide 8 by 4? For sure, that's 2, right? So we'd keep the 2 in the top. We have that x to the third. And then maybe just right now, let me just take care of this. This negative exponent here with the y would actually move to the top of that fraction. So really, I did not do a second power on this at all. I just simplified the fraction that I had there. That y to the negative 2 would move up and become y to the positive 2. 8 divided by 4 is 2. So the entire denominator of that fraction cancels out if I simplify it first. And then I'm just doing a product to a power here. 2 squared would be 4. X cubed to the second would be x to the sixth. And y squared squared would be y to the fourth. Does anybody have a question? Okay, I'm going to run through all of these like as fast as possible down here because I got a couple more and I know we don't have a lot of time. All right, now product. Multiply the numbers. So I have 5p squared and a q, 2p squared and q to the ninth. So just straight up multiply numbers out in front. So 5 and 2, multiply those together, you get 10. Okay, now you're going to add the exponents on the letters that are the same. So I have a p squared and a p squared. So we would have 4 p's. Now the q's tricky here. I just have q. All right, now they're not going to write that in there, but if you just have a plain q by itself, it's there, right? So it has an exponent of 1. How many q's do I have if I multiply those together? 10, right? You got 1 here, 9 more here, so we have q to the 10th. All right, same thing here. I'm going to multiply the numbers, add the exponents on the letters that are the same. So negative 4 times negative 2 is positive 8. Those are not negative exponents, they're just negative numbers I'm multiplying together. Okay, now my x's, I've got 2 here, negative 3 here. I'm just adding these exponents. That would be x to the negative 1. I'm going to simplify that in a second. And then I have y to the 5th, y to the negative 2. Just adding these exponents, 5 plus a negative 2 or 5 minus 2, we would have y to the 3rd. The only thing I'd have to do real quick is move that exponent where I have the negative 1. Just move this down. So you'd have 8y cubed over x. I'm just going to skip this next. I want to do a couple of these fractions with you. Okay, now I cannot simplify that fraction in terms of like top and bottom because the top has a squared. So you have to square the top first. So 12 squared, you got 144. Power to a power, I'm going to multiply my exponents. So I'm going to have x to the 4th and y to the 12th on the top. On the bottom, I'm going to have 8x to the 4th and y to the 7th. I just copied that down. Okay, now, here's the deal. I'm going to take my calculator. I'm going to see, I actually think 8 goes into 144. So I'm just dividing those two numbers. That is 18. Okay, where do you have more x's, the top or the bottom? Trick question, it's a tie, so they cancel each other out, no x's. All right, now I have 12 y's on the top, 7 on the bottom, so I have 5 more on the top. You do not have a fraction, and the x's cancel out there. Okay, now let me do these two at the bottom. All right, so I'm going to just see, I don't think 18 goes into 60, so I'm going to do my math, enter. All right, so this is 3 over 10, and if you move negative exponents, you'd have x to the 7th, and I'm going to move this x to the top. You're going to move y to the 6th to the bottom, so you'd have 4, and you move 6 to the bottom. I'm just finishing this up, and I'll be quiet. All right, so when you move them, if it already exists, I'm going to move 1 up. So I had 7x's up here. If I move that one up, you should have x to the 8th. Then you're adding them because you're multiplying like bases. Same thing with the y's. So move the negative 6 down, make that positive 6. Then you got a product on the bottom. It'd be 10y to the 10th. So sorry, you guys. I talked that whole time.